conditional expectation. So you can calculate. You can also ask the same kind of a question that, okay, how about if you have the conditional expectation of some of the random variables that goes from I equal to 1 to n xi, given y is this fixed number of 1. This is same as that you sum I equal to 1 to n, conditional expectation of xi given y equal to y. So the conditional expectation of the sum is the sum of the conditional expectations actually. Okay? So this is what, it's not difficult to. Sure, I mean, if you wish, you can try to attempt to give it a proof. The proof would not be different from what you had in case of the expectations and means unconditioned expectations and what do you call unconditioned expectations. You're going to get this. The next is an interesting part, and that part says that, okay, what if I want to compute the expectation? So another way to compute the expectation of, say, a random variable. So in other words, the expectation of a random variable x can also be computed by the conditional expectation of x actually. Okay? So the expectation, computing expectation of x. So next is about, the next formula is about computing the expectation of x using expectation of conditional expectation x given y. Okay, so I want to compute this using this actually. Okay. By the way, if you carefully analyze, we'll talk more about it when we'll do what you call our stochastic stuff actually, that the conditional expectation itself is a random variable. So it's, if you treat conditional expectation of x given y as a function that takes the value y and gives output, what do you call the conditional expectation of y given y, then this function is well defined actually. And it's not only well defined because these values are random, this shows that this function is also a random variable with respect to the random variable y actually. So if this function is a random variable, okay, with respect to the conditioned random variable and with respect to the random variable on which you are doing the conditioning, then I should write it explicitly, that expectation of x given y, okay, is a random variable, okay, with values okay, with respect to y actually, okay, with respect to the random variable y, okay. So you can treat this function and you can show that this function is well defined, and conditional expectation, by variating y, you can treat this as a random variable as well. So if this is a random variable, you can ask an interesting question. So expectation of xy, okay, expectation of x given y is a random variable. So if it is a random variable, you can ask a question, okay, what is the expectation of this random variable? Okay, so in other words, what is the average value of these conditional expectations actually? So what is the average of these conditioned averages? The answer is, this is equal to the expectation of x. Okay, this is equal to the expectation of x. So this is a proposition that I want to prove. That the expectation of the conditional expectation of x given by, okay, this expectation has been taken, on the values of y actually, okay, and this is equal to what you call expectation of x. So the average of the averages, conditioned averages, is equal to the average of x, okay. So this kind of allows you to calculate the average through the conditional expectation actually, by computing the average of the conditional expectations. Okay, so that's what I mean, that computing expectation of x by conditional expectation. Okay, so let's prove this result actually. So let's just start with, say, conditional expectation of x given y. Okay, x given y. As I said, this outer condition is really conditional expectation on y actually. So I can write this as that this is equal to the sum over the values that random variable y takes multiplied by conditional expectation. So when y is taking the value y, what would be the value of this random variable? The value of this random variable is going to be expectation of x given y equal to y times probability of y equal to y. This is what it is going to be. Okay? So this expectation is for the random variable y. So this means that I need to take the sum over the y, the values that y takes. So what would be the value of this conditional expectation when y is y? So it would be this value multiplied by the corresponding probability. And now let's simplify this expression. This is going to be the sum over y. I can also write this some more explicitly, that this is going to be x, and the probability that x is what do you call x given y is y, and with this sum this number is multiplied. So if this number is multiplied, I can multiply it with each term of this sum. Okay, each term of this sum. So here I substituted the sum and then multiply that sum with this number. So this number will be multiplied with each value in this sum. And now I can simplify this expression by sum over x. So this is going to be the property of x equal to x, y equal to y, and everything divided by property of y equal to y and property of y equal to 1. And hence you can get rid of these probabilities. Okay? You can get rid of these probabilities. And once you have this, you need to also multiply this with x because we are talking about the expectation of x. So the expectation of x is x multiplied by the conditional probability that x is x and y is y. When you simplify, you get this actually. Now, if I, switch this term, if I wish, so it's kind of independent sum, so if I wish, I can switch this sum actually. So I can write, say, y here and x here. There's nothing wrong in it. And you're going to get x times the probability of x equal to x and y equal to y. Now since this sum is on y, so this x is really independent of the y. So if I wish, I can write this x here. So in other words, x would be multiplied with each probability. So if I wish, I can take this x common. So I took x common and I remained with this expression. So when I remain with this expression, what will remain? What will remain? Can you recognize this? So the probability of x equal to x is fixed and y equal to y is changing actually. So I can write this as, so this is like the marginal PDF actually, the marginal PDF, okay, so I can write this as sum x and this is equal to, maybe you can treat this as that this is like using, so it's like, okay, if the what are the probability when x is x and y is changing its value? So when x is x, y can be anything. So I can put this sum in a form of a single probability, which is what the probability that x is x. Because if you want to compute what is probability x is x, this is same as saying that y can take any value. So what would be this sum x times probability of x? So this is precisely what the definition of expectation of x is. So we kind of showed that if you compute the conditional expectation of x given by, okay, over y, then this expectation is equal to expectation of x actually. So you can compute the expectation of x by computing the expectation of the conditional expectations on y. Okay. So I hope that these calculations makes a bit sense to you.